Hi there. This is a video about transformations. And a transformation is when you move an object or change the size of an object. And we have two kinds of transformations. You have a rigid transformation where it doesn't change size, so doesn't change size. And then you have a non-rigid, which means it does change size. All right, so changes size. All right, so let's talk about the rigid transformations. And in a rigid transformations, we have three kinds. Okay, we have one that's called a reflection. We have a translation. And we have a rotation. All right, so when I think of a reflection, I use the word mirror, okay, to talk about what a reflection is. All right, a translation is a slide, all right, and a rotation is like the arms of a clock, okay? So those are just the basic ways to show all these different rigid transformations. Again, if we reflect something or translate or rotate, then those don't change size. All right. Now we'll talk about some non-rigid ones right now. We'll focus more of this study on this later on when we talk about similarity. But the two that we have is called a dilation. Okay. And then we have what's called a stretch. All right. So remember that these change size, okay? These are either going to get bigger or smaller, and a dilation is when all dimensions are changed, and a stretch is when one dimension is changed, all right? So, So those are the five that we're going to talk about, okay? And we'll talk a little bit more about what these are, but I want to talk a little bit more about some other vocabulary associated with transformations. Okay, the first thing I want to talk about is this concept called a preimage and then an image. A preimage is where you start. An image is where you end. I also like to use the phrase the original, okay, which is also called the OG, and then the result, okay? These all kind of mean the same thing. You'll see more of pre-image and image, but I want to at least make sure that you understand what those mean. Okay, so let's take this triangle here, okay? So I have this object, and what I'm going to do is I'm going to just translate this, okay? And this is what I call my pre-image, okay? This is where I start. This is my original or my OG. Now let's translate it. And so if I come here and I move this piece over, okay, then all of a sudden I have an image. This is my end. This is the result of transforming this, all right? So what I want to do is also call this something, all right? So I'll call this triangle A, B, C, and I'm going to call this one over here A prime, B prime, and C prime, okay? Now, a couple things that I notice here. I notice that I have congruent segments in each of these. I know that if I label BC with one tick mark, it's going to be congruent to B prime, C prime. AB, I'll use two tick marks, and then A prime, B prime will also have two tick marks. So those are congruent. All right, AC, I'm going to use three tick marks, and A prime, C prime will also have three tick marks, okay? The other thing I know is that not only when I do a rigid transformation are all the sides congruent here to here, but all my angles are also going to be congruent. All right, so angle B and B prime are going to be congruent. Angle A is going to be congruent to angle A prime. And then angle C, which we'll call this a right angle, will be congruent to C prime. Okay, so notice that all parts here are going to be congruent to all parts here. Let's talk about this other word called correspond. Now, correspond or corresponding parts means the same position same position from the pre-image to image, okay? So let's talk about corresponding points, okay? And when I talk about corresponding points, what I'm really saying is that point A corresponds to point A prime. That point B corresponds to point B prime. And that C corresponds to point C prime. Okay, we can also talk about segments, okay? So segments, if I were to say segment AB, okay, that's going to correspond to segment A prime, B prime, okay? If I talk about segments BC, then I can say that that's going to correspond with B prime, C prime, okay? The last one I would say is that segment AC is going to correspond with segment A prime, C prime, okay? And that's the idea, all right? So when you've got something like this, you've got points that correspond. So A becomes A prime, B becomes B prime, C becomes C prime, and so on. So those are the things that I want you to notice here, all right? Now, we could also say this, all right, that triangle ABC corresponds to triangle A prime, B prime, and C prime. Now, what I want you to notice about this is that the way that I name this triangle here as ABC, and that's my image, how I name my pre-image, sorry, this is my pre-image, this is my image. How I name from this statement to this statement is how these things correspond, okay? So let's look at another example. Okay, the next thing I want to talk about is a reflection. So I have this triangle here, which we'll call triangle DEF, okay? And what we're going to do is we're going to reflect that across this line here, okay? So again, a reflection is like a mirror, all right? So I'm just going to reflect point E over, point F over, and point D over. And once we reflect this over, so what I've done is I've just reflected this over, and it's not exactly perfect, but you get the idea. And so what I'm going to call this new triangle now is triangle GHI. Okay, and what I want to do is talk about what corresponds with what. All right, so let's write out our corresponding statements. And so the first thing I want to say is that if I'm writing this out formally, I'm saying that triangle EFD maps itself onto triangle HIG. Okay, and so what that means is that point E corresponds with point H. Okay, and notice how that's the first point that we've labeled when we make this statement. Okay, let's talk about point F and I. So those map onto each other as well. So F corresponds to I. D and G are the third one, so we would say that point D corresponds with point G. All right, so that's the first set of corresponding statements that I can make, is what points correspond to what. The other thing I can say is that in a reflection, since it's rigid, EF is congruent to HI. Okay, so let's write that out, that EF corresponds to HI. Okay, and that FD corresponds with IG. So FD corresponds with IG. And then the last one, that ED corresponds with HG. Okay. Now, the other thing that I want to say here is that even though these correspond, all corresponding statements, all right, segments and angles, they're congruent. All right, so let's write out some congruence statements. All right, and let's start off with just saying that EF is congruent to HI. All right, and that FD is congruent to IG, and that ED is congruent to HG. Okay, so those are the congruent statements that I can make here. Now the other thing is that since all these points correspond with each other, all right, I can also talk about how angles are congruent. All right, so I can come in here and say that E is congruent to H, F is congruent to I, and that D is congruent to G. Okay, and so let's write that out. That angle E is congruent to angle H, that angle F is congruent to angle I, and the last one is that angle D is congruent to angle G. Okay, and so that's what I'm doing here. All right, so just given this statement here, that one triangle is reflected and maps onto another triangle, we can make all these corresponding statements, and we can also talk about how all these congruence statements exist, okay? And that's all I have for this video. Hope you enjoyed it, and we'll see you soon. Thanks. Bye!